think we're moving it.
I think so.
Yep, that's me. You're probably wondering how I ended up in this situation. Well, it all started a couple months ago, when I bought this lathe. This thing is over 70 years old at this point, and it's actually pretty cool. I'll let past me talk about it.
It's in pretty decent shape. Like, the ways are not bad, no dents. I'm sure there's a dip in it, but none of the work I'm doing is precise enough to where that matters.
Wow, way to undersell yourself. Yeah, it has a couple other features too. It's got
Gaps in what matters, things that aren't working. I'm not sure if that in this I don't know what this is, but I mean,
okay, some real features.
it's got a couple accessories. It's got the 3-jaw chuck. It has thread cutting abilities. These are all the change gears. A 10 by 40 or 48 lathe. It's very old. It's an Atlas Craftsman when Craftsman was Atlas, and they actually sold decent tools.
It also has 4 speeds, times 2 at the motor pulley, times 2 again with the back gear. So 16 in total. But yeah, I'm gonna bring this thing back.
Back to its original, beautiful, not disgusting.
Now, I'm not sure about original and beautiful, but it'll certainly be less disgusting. So yeah, join me in this restoration of a 70-year-old machine. It's gonna be interesting.
I'm trying to push this shaft, but nothing's able to get it off.
Okay, so first off, what even is a lathe? Many of y'all probably already know what a lathe is, but this video is for people my age, and some people my age don't even know what a wrench is, so I don't want to take any chances. Well, I hope you at least know, or have seen, a milling machine. And a lathe is just a milling machine on its side, with one less degree of freedom, but also somehow way more versatile. This is my Shoreline micro lathe. It may be small, but it's not about the size of your micro lathe, it's how you use it. Lathes are used to make cylindrical, concentric parts with a high degree of precision. I have the smaller one because they provide finer control and feedback than larger ones, which is especially important for the kind of work I do. Now we'll start talking about what makes up a lathe, and to do that, we'll finally jump into the build. First thing on the agenda is the lathe table. Now, I like my machines like I like my women, and that's with a sturdy base. And if there's anything this table is, it's not sturdy. Yeah, I don't know what the last guy was doing when he was making this table, but it's certainly interesting. In retrospect, I should have just bought a better table, but I didn't, so you're gonna have to watch me solve this. So the first thing I want to tackle is the tabletop, mostly because at this stage, I didn't know just how wobbly this thing is. So the first thing I tried to do to remove all this 60-year-old dirt, rust, and grime is use some rust remover. Boy howdy was I in for a treat.
And of course, as it goes with random gel chemicals, it actually made it so much worse. It left this like green cakey residue on it that I've tried so many things. I've tried just rubbing it off. I've tried using this degreaser. I've tried using paint and varnish stripper. I have tried using carbon choke cleaner. I have tried using brake cleaner. I have tried using acetone. I've tried using ammonia. I've tried using mineral spirits, even friggin' Windex, and nothing is able to get it off.
Yeah, I don't know if it's just a skill issue or if this gel stuff is just garbage, but I'm gonna do what I should have done from the very beginning, and that's just abrasion. I'll be using the tiny Milwaukee with a scuff pad to remove everything.
Because there can't be any scum when the scum isn't there.
And here's the finished product. And you can see I'm giving y'all no time to oogle the finished tabletop because I didn't record any B-roll. So the next part is dealing with these awfully bananaed feet. Fix these feet, I'm just not going to use them. I will convert this table to one with leveling feet, that way I can also use the leveling feet to level it. Because surprise, this table isn't level either. These feet are going to raise the table off the ground so that the undulations in the table feet and legs are completely canceled out.
One eternity later.
And finally, we can install the adjustable feet. They're simply these 3/4 inch bolts with some nuts to be able to adjust the height of each foot independently. But before we can do that, I need to fix these bolts. You can see the bolt head has these identifiers embossed into it, and these would create high points that would reduce rigidity. So I want to make these smooth and, more importantly, flat.
I can explain.
Okay, so if you know anything about machining, you know this right here is sketchy. This much stick out on this size machine in steel is just asking for chatter. And if you don't know much about machining, you'll be asking, what is chatter? Well, chatter is sin, chatter is the devil, chatter is the bane of all machinists. Chatter is the harmonic vibration due to a couple different factors, but in short, the savior of this is rigidity. You can see here, there's not much rigidity to go around. The solution in this scenario is just lighter cuts. Lighter cuts prevent the part from gaining enough energy to harmonize. So here I'm taking just 0.02 of an inch off on every pass. This takes patience, but an impatient machinist is a partless and fingerless machinist. And I finally pushed past the embossing, and now I'm facing the head bolt until it's completely smooth. Since these threads are so thick, I didn't have to worry about the chuck jaws damaging them. And surprisingly, this whole operation went surprisingly well. Good job, little Shoreline.
Nice.
So now you can see the bolt head rests on the ground, and since it's been machined flat, it now sits flat. That lower nut acts as the height adjustment, and the nut on top is a jam nut to hold the height position solid. Alright, now we can finally work on the lathe, the thing we all came here for. The first and most important part of a lathe is the lathe bed. This is where most of the mass and rigidity of a lathe comes from, and it holds the ways. These are where everything on the lathe operates, and it is imperative that they are flat and smooth, of which these are not.
It's like an actual dip.
This groove comes from poor maintenance and lots of use of the carriage, which slowly wears down the ways. But I can feel this groove, which means it is at least 3 to 4 thousandths of an inch deep, which is a lot. But there's not much I can do about it directly. I can make some adjustments with the carriage to isolate the issue, but we will get to that later. For now, I'm just going to degrease, derust, and stone the ways to make them as flat and smooth as I can. This here is not a precision ground flat stone, but it will still help a lot with knocking down the burrs that can reduce rigidity and mess with accuracy. You can hear the stone grab onto the high spots. These deformations in particular are quite stout. I presume these came from the last guy dropping chucks on the ways. This part of the way sees the most abuse in chips, oil, debris, parts, and just dropping random crap, since it's right in front of where the headstock sits. Alright, and as you may have noticed, I added this plate here. The tabletop is a very flimsy piece of metal, and it would not only act as a tuning fork and amplify any vibrations, it would also reduce rigidity. So I added this stiffening plate that redirects the foot of the lathe bed to the frame tube, so that it doesn't rely on the tabletop as a mount. Now the tail end foot is a different story. The bolt hole sits directly above the frame tube, and you might say that's great, but it brings a different issue. But this is easy enough to solve with skinny arms like mine. So the lathe is finally mounted. It is mounted a little weird though. At the head, the base plate only covers a portion of the foot, and at the tail, the foot tapers away from the tabletop. On some lathes, this lack of mounting surface area can be a big issue, but in this type of tabletop lathe, with uneven bed feet, much of the stiffness is transferred through the surface area directly around the bolts, and those are firm. So a little odd looking, but relatively inconsequential. Regardless, this type of lathe is designed so that the mass and stiffness is built directly into the lathe bed. And now it's time to clean all the parts. Yeah, so that was my only clip I recorded of cleaning all the parts, but it was basically just that over and over and over again. And this black rag you see here, this was white when I bought it.
You know, these were white when I bought them.
And here's all the parts after they've been cleaned. This here is the headstock. It is the part that makes a lathe a lathe. It holds the part via the spindle and spins at a specific speed in order to make the correct type of cuts. It also is extremely rigid while still providing enough free play to be able to spin at the correct speeds. Now if you recall, there's
Gaps in what matters.
So the problem here is that the back gear sits too close to the spindle gears. I presume this is why the previous owner just left this gap here so that it could still function, but I'm going to fix it. Thankfully, the problem is only on one side, so I can just make a simple riser block. You can see now the clearances are perfect, but before this plate, the back gear was cocked at an angle and did not allow the spindle to spin. I'm not exactly sure why this is like this, perhaps another part mounted in between the back gear bearing block and the headstock. Regardless, it's fixed now. Okay, next thing to tackle is the pulley support bracket. So let's go back in time. Okay, so this back here, I can tell this thing is cooked based on the condition of the rest of the machine. The bushings are definitely galled, and the shaft itself looks to be in poor condition as well, so I want to replace this. Oh, what a mistake that was. Yeah, so the shaft was so deformed and mushroomed that it moved about half an inch before it started fighting for its life.
I'm trying to push this shaft out of all these pulleys and everything, and they're really binding up, which is not a good sign. I have it clamped in the back here, because if I did this without this clamp, this flimsy little cast iron piece would absolutely crack in half and be destroyed. My biggest concern is, oh my gosh, look at that, bro. But my biggest concern is that some of these holes are going to look like this, where this is mushroomed out, and that means when I push it out, it is going to absolutely ruin these brass bushings. So, I'm just gonna continue.
Once I got it just far enough to remove the belt, I was able to take the whole assembly off the machine and get it apart the easy way.
Okay. Yeah, so I'll heat this up, and then once it's heated up,
do the tappy slappy.
yeah. You need one of those steel rods on there?
Oh, I got a steel rod for ya.
What do you mean by that?
Okay. God damn!
Is it hot?
Yeah, I think so. I just don't.
Hmm.
Doing the same thing, or
Yeah, but with a longer thing.
why would that make any difference?
I don't know. Maybe it was me. Maybe I was just being a little pussboy.
Yeah, that's hot. I think we're moving
I
it.
think so.
That's okay.
Oh my gosh.
Yes.
Ah!
Oh my gosh, it's
Is that it?
no, hold on, move it. All right, keep going. Ah,
Woo!
thank you.
It worked. Man, I wish I was using my jack-off hammer. I'd be so tired now.
That oil is cooking. Oh, God. Okay. Bro, did you let coal back in?
Oh yeah.
Okay, let's take a look at these bushings. Yeah, those are pretty cooked. From where and from, well, you know. And here's the shaft. Yeah, both pretty destroyed, so I'm replacing them. I got this new shaft and brass bushings sized for each other so that they run nice and smooth. But to get these bushings in, I have to get the old ones out. And to do that, I'm going to have to make a pusher. It appears here that the pusher is slipping and can't dog into the right part of the bushing, and it's just pressing against the support bracket. So I added a second shoulder that aligns it better. And I finished taking them out off screen using the vise. Okay, so the old bushings were the oil-soaked type of bronze. If you don't know what that is, that's a type of bronze that soaks up oil. The new ones are not, so I have to make an oil passage for them. I have these drill bits resharpened to cut brass. If I didn't, they'd be acting all kinds of weird right now. Brass requires a different cutting angle from steel, and if you just use a normal steel drill bit, it'll grab the part out the wazoo and destroy your holes. And I deburred the inside and outside of those holes off camera. Even the smallest burr on the inside would completely destroy the fit. So now it's ready to be pressed back together. And I'm just going to use the vise to do that. And it's very important that the oil holes line up with the oilers. You might be thinking that the press fit will squeeze the bushing so that it becomes too tight, and you're absolutely right. So after I pressed these in, I refinished and repolished the inside just enough to where the shaft fits perfect again. Then I deburred the openings of the bushings since the vise jaws leave some marks. Alright, finally time to put this thing on. I attached the motor bracket just before this as well. This whole bracket hinges on one point and it uses the weight of the motor to tension the belt, which is pretty ingenious. And after that, I can mount the headstock. This thing is attached on the back and one clamp in the middle. This allows the alignment to be adjusted, which is something that needs to be done whenever the headstock is taken off and every now and then to maintain accuracy. The center line of the headstock needs to be perfectly parallel with the ways, otherwise the tool would cut a taper into every part. Now I'm going to do what the last guy should have done, and I'm going to create some flats for the set screws to set screw into, so that when the time comes for disassembly again, we won't have another. So first, I'm going to mark where the land needs to be using its own set screw, and then I'm simply going to file that land down just enough so that the dimple formed by the set screw doesn't exceed the shaft's original diameter, and it can still slip freely through the bushings if there's any need to take it apart again.
One debt to society later.
You can see the flats are not aligned. That's perfectly fine. I didn't try to align them. It'll just mean that when I put the pulleys back on, I'll have to be a little more conscientious. Next, I need to rewire this motor. They had it wired very weird.
Wow, those were just dangling there.
Yeah, whoever wired this motor last had the wires just raw dogging this metal enclosure. No solder, no heat shrink, no wiring nuts, nothing. Thankfully, this motor has a wiring diagram for me to rewire it for my circuit properly. There are normally several different wiring configurations for these kinds of motors: counterclockwise, clockwise, 240 volt, 120 volt, etc. I need clockwise at 120 volt. Now I'm going to hook it up to my surge protector so I can test it safely, and I'll do it on the floor just in case it might rattle or burn my bench to pieces. And before you say anything, safety is always my #1 priority, so here I'm wearing my steel toe socks.
Okay.
Now that the motor isn't letting out the magic smoke, we can move on to permanently soldering these connections.
Using this to displace all the flux.
And you may notice I forgot to heat shrink, so I redid all this with heat shrink off camera. Trust me. I have the motor loosely bolted to its mount, so I can now test how it works with the belt on, but it seems to be fighting me. So I don't think this motor was original. If it wasn't obvious by the fact that it actually worked, it also doesn't allow for much room. But I have an easy solution for this.
Okay. glad I'm taking this out anyway.
So this is just a startup capacitor. It does what you might think. It's similar to a retroencabulator, which provides
inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal gram meters.
Oh yeah, that's perfect.
And after this, I tightened those bolts down so the belt was at the correct tension. I didn't show it, but I also temporarily fastened that capacitor down. And now we can move on to the other parts of the headstock. This set of gears I'm putting in right now is the forward and reverse of the back gears.
Bro, what chef doesn't taste their ingredients? I will take a bite out of every single thing every step of the way.
Okay.
This whole back of the headstock is what controls the gear ratio between the spindle and the cross slide down feed by changing out gears with different ratios. Hence their name, change gears. This funny looking bracket is what allows the user to adjust the proper depthing of the different change gears.
Yeah.
This part is the beginning of the lead screw. This is the final set of components of the power feed on this end.
Go.
Next is the carriage. This is the magician of the lathe. It is what makes the difference between gross woodworking and precise metalworking. The carriage is what enables the machinist to control the tool on 2.5 axes in order to do all lathe work. One of the most important parts of the carriage is, and say it with me, rigidity. The carriage needs to be adjusted in 2 dimensions so that it is as stiff as possible while still being easy to use. And I am adjusting that first dimension here. The clamps on the bottom of the carriage need to be shimmed to the exact thickness of the ways themselves, so that there is no up and down shake, which could cause the tool to jump and chatter. But this lathe presents an issue with that groove.
There's a little bit of oil right there. I have the bottom plate bolted on, and when I lift it up, you can see the oil wick out. That's how you know it's not seated completely, but this is a very little amount because the oil isn't completely wicking away. I have a 3 thou shim, and that doesn't fit, so it's less than 3 thou, which is acceptable to me. Well, not very acceptable, but it's okay. And then the reason why I have to run it loose is because when you bring it over here, toward the back, it starts to bind up. It's still movable, but it's quite bound up, and the reason for that is because that wear groove in it, that 3 or 4 thou wear groove, that's only in this area and not in the back area. So it's loose here, but too tight over there. I'm gonna try to go 1 thou thinner and see how it acts over here. Because 1 thou thinner should be rock solid and tight back here, which I'd prefer it to be too tight than too loose.
Next part is the gib. This prevents the carriage from wobbling left to right. Or is it forward to back? I don't know. And this number you see me doing a lot of the time where I wipe off a part is a pretty common and pretty necessary machining habit. It wipes off any debris from the part so that it sits nicely. Even the tiniest amount of a metal chip can completely screw you up. This gib does not use shims as its adjustment. It has 4 screws on the back that allow the gib to be tightened. Here I am sliding it back and forth until I feel the desired amount of resistance, and 0 shake. This is quite a tedious process.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Next up is the apron. This is the brains of the carriage. It's where all the power feed is transferred through. This first section of gearing is what operates the power crossfeed. It takes the rotational action of the lead screw using this key and drives it to this gear, which operates this screw, which controls the cross slide. This section is the half nut. This engages with the lead screw to drive the cross slide for power downfeed and threading. Many higher quality lathes have a separate mechanism for power downfeed and threading because the half nut wears down easily with all the cutting forces pushing against it during power feeding. Maintenance like this also doesn't help.
What the hell is even that?
And remember, this is what it used to look like. This last assembly is simply the gear train for the carriage handle. It brings the rotation of the handle to the gear rack on the ways. And it's finally time to actually turn it on. I have this hooked up to a GFCI outlet just in case there's some grounding issues. Obviously the switch here on the bench is temporary. Last thing to do is oil everything that needs to be oiled, and there's like 12 points on just the headstock that need oiling, and half of that oil will proceed to fly out as soon as it's turned on. Behold, a finger breakinator. Okay, so first thing I noticed is that it turned on, and second thing I noticed is that it's shaking quite a lot, and that's a no-no for a couple of reasons. First, it'll make recording awful. Second, it'll likely ruin any surface finish on a part because the vibration will be imparted onto the tool. The shaking can be due to a couple of things. First is the belt. If the belt is deformed, which it likely is since it's so old, it will unevenly push the pulleys in and out. Second, the shaft for pulleys are misshapen or imbalanced in some way. Misshapen would be more likely since it would cause the pulley, again, to oscillate. After that are a lot more complicated reasons, so we'll get to those later if need be. I'm replacing these belts with twist lock belts for easy replacement in the future. This also prevents the issue of the V-belt forming into an oval like the last one had. Also, replacing the spindle V-belt with a new V-belt would involve taking apart the spindle, which would involve more of this. Whoa, hold on there, Buster. Okay, so these green belts are the twist lock belts. I installed these off camera. It's important to note that these are directional. The little nubs face backward. Okay, so once I turn this back on, I want you to watch a couple of things. First is how much it's vibrating. And second, pay attention to this pulley here. Okay, but listen to the difference already. Alright, so yes, it is still shaking, but a lot less now. So the belt was definitely part of the issue. And the other thing, that pulley up there seems to have some undulation. You'll also notice when I relieve the tension on the belt, you can hear the vibration stop. This points to it being a concentricity issue with that pulley, rather than a mass imbalance, which would happen regardless of tension, since that would transfer through the bracket to the bed. So let's check out this pulley.
What the hell? Oh my god!
Alright, I'm going to make an adapter sleeve for this pulley, since I do not want to wait for a new pulley. This will be a pair of simple bushings with a little lip on them to act as the shim in between the pulley and the shaft to center it correctly. The awful noise you're hearing is the aluminum crystals screaming as their families and friends are torn apart and flung across the shop. Aluminum is gummy and a very tight-knit community, and hate to do this to them, but I own the stock, and landlords got to do what a landlord's got to do. And if that means flinging them at mock piss missile, then so be it. Yeah, some material just screams at you on certain tooling, but it's not bad for anything, except for your ears and the families. And this right here is why you should always sharpen all sides of your tooling. You never know when you're going to use the backside to do cuts. And I can't just machine it normally, since this piece is so large, the carriage actually runs into the part. So I have to chip away at the diameter until I can cut it normally. Here, I probably could have just sent it and went to the largest drill bit off the bat, and it'd probably be fine, but I didn't do that, because 1, this is good practice for tougher metals, and 2, I didn't think about it. You will notice a slight wobble on this larger pulley. This is the inside chamfer that looks to be poorly machined. I don't notice any concentricity issues with the actual V-groove though. We will see if this presents an issue.
Yeah, that's adequate.
Alright, now that the headstock is all squared away, we can finish the rest of the carriage. This is the cross slide. It has 2 lash adjustments. One is the nut on the underside that engages with this screw so that the hand wheel can drive it. The other is the gib that controls the tightness on the dovetail. This here is the aforementioned lead screw. It is what delivers the power from the headstock to the carriage for it to perform power feeding. This low bracket is replacing the old.
I don't know what this is, but I mean,
It's 3D printed, but that is actually on purpose. This acts as a weak point so that if the lathe crashes, it breaks and nothing else does. And this part is easily replaceable now. This is the thread dial. Sometimes when thread cutting, you need to land in a precise spot on the thread, and this dial essentially tells you where your cutter is in relation to the thread. This here is the compound. This is built on a swivel so that the next part, the top slide, is able to move at any angle. This allows you to cut tapers and other angled features. And now the top slide. This works similarly to the cross slide, where it is operated by a screw and controlled by its hand wheel. The only difference is it's on top of the compound. So once again, it is able to cut at any angle. And finally, the tool post. This here is what's known as a 4-way tool post. This allows you to put any tool, to a certain extent, in at the right height using shims. This here is a carbide insert cutting tool. So now we can finally make some chips. Alright, now while the tailstock is being put together, I'll do a little outro. I'm hoping this video style turns out well. I certainly put a lot of time into it. This channel is going to become a source of something that is significantly lacking in the modern internet space. It will be a source for horology, the study of time. There seems to be almost no horological stuff on YouTube, so my first couple series will be stuff like horology basics, clock basics, eventually getting into the actual design and physics of clocks, shop and machining stuff along the way. And soon, actual clock builds, big and small. If you're a fan of ClickSpring and Brandon from Inheritance Machining and my Gen Z humor, you'll hopefully enjoy what this channel has to offer. And the final step of a lathe restoration is to pack everything up, move 100 miles away out of your parents' house, and upgrade your shop to about 3 times the size. And that's where we are now. My name's Schmidt. This is my shop. Okay, bye.